Assalamualaikum and a very good day to my panels, Encik Muhammad Hatta bin Jofri and Encik Mustafa bin Manab. Okay, my name is Nufarzana Afika binti Zaifuzaman and I'm from BEEI. So today, I would like to present my final year project 2, which is mitigation of false tripping in distribution network with distributed generation penetration. This is my poster and I will explain each part in the next slide. I will start with my introduction. Okay, distributed generation DG is the production of electricity from small-scale generators that are situated closer to the customer or consumer, usually at the distribution stage. Okay, DG is a form of electricity generation that derives energy from a variety of renewable energy sources, and it is typically connected to medium and low voltage distribution system. Special consideration must be made in order to produce and deliver electricity to customers in a safe and reliable manner. Okay, so this is my project objective. Okay, the first one is to simulate the tripping time of overcurrent relay during fault with the presence of DG on the grid system by PSCAD. Okay, second, to analysis the fault tripping with the presence of DG using power system computer aided design PSCAD software. Okay, the third is to mitigate the fault tripping with the presence of DG using PSCAD. So for the problem statement, the presence of DG can cause many challenges such as a protection blinding, false tripping, undesirable network islanding, and asynchronous reclosing. When a large-scale distribution renewable energy source DG are integrated into distribution network, the fault current flow in a both direction of the majority of feeder and lines. When a DG is close to a fault and start engaging in fault current that approach the peak limit of the healthy feeder, erroneous tripping of protective device or sympathetic tripping can occur in the distribution network, causing tripping of a healthy component of the network. Okay, so this is my methodology. Okay, this project is started with the project research by reading some books, journal and articles. Then I do the theoretical modeling and data calculation. Okay, so as you can see, this is my data calculation with different size of DG. Start with 1 MVA until 1000 MVA. Okay, so next I do the simulation using a PSCAD and then record the simulation data and analysis, and then lastly discuss the result that I get from the graph. For result and analysis, okay, there are two situations we want to investigate. Okay, the first is fault at A1 and fault at A2. Okay, so as you can see, this is the table for the simulation result of relay condition for distribution network with DG at bus C. Okay, for relay condition, 1 is trip and 0 is not trip. Okay, so as you can see from this table, for initial condition, 1 MVA and 5 MVA, okay, MVA is in normal condition, but 10 MVA until 1000 MVA, they are false tripping occur at relay B. Okay, this means show relay B is state 1. Okay, so to mitigate this problem false tripping, okay, I have added additional supply at bus B and bus A. So this is the result when I add the additional power supply at bus B during fault at A1. Okay, so the relay A is remain stripped. Okay, so for B, when we add the additional power supply, okay, the relay B is not tripped, which is improved. Okay, for the next, okay, additional power supply at bus A during fault at A2. So it show the relay A is remain stripped. Okay, And for relay B, okay, it's only not trip for 1 MVA, 5 MVA, and 10 MVA. And others, okay, start with 50 MVA until 1000 MVA. It's really still experiencing false tripping. Okay, so this is the simulation circuit using PSCAD. Okay, I will take the example using a DG sizing 100 MVA. Okay, so this is the parameter for DG sizing 100 MVA. The resistor is 0.4188 and the inductor is 0.0346 Henry. Okay, so this is the initial condition. Okay, with DG distribution generation at bus C, and fault occur at A1, which is line AB. Okay, so we start build the modified circuit. Alright, and then we run the simulation. Okay, so as you can see, there is a fault occur at line A1. Okay, so as you can see, so this is the relay A trip time and relay B trip time. So for initial condition, okay, relay A and relay B is trip. Okay, 1 is mean trip and 0 is not trip. Okay, so as you can see, relay A and relay B trip. For this condition, it should have relay A only trip, but relay B also trip. Okay, so if we want to mitigate this problem, we add power supply. For example, okay, we add on bus A, and then we build the modified, and then run the simulation. Okay, so as you can see, this is the new result. Okay, for relay A, it trip, and relay B is not trip. Okay, that's mean there is no false tripping occur in this situation. Okay, because we add power supply on bus A. Okay, so next we go to bus B. Okay, so we add bus B, additional power supply on bus B, and the fault is still occurred at A1, which is line AB. Okay, then we build the modified and run. So the fault is still occur at A1. So this is the result. Okay, so as you can see, when we add power supply at bus B, it also happens same as previous. Okay, so relay A trip and relay B does not trip. So that means there is no false tripping occur. Alright, thank you. Okay, so we go to next example. Okay, so this is a 500 MVA. Okay, this is the parameter for DG sensing 500 MVA. So the resistor is 0.0838 ohm and the inductor is 0.069. Okay, the DG is still on bus C and the fault is occurred at A2. Alright, this is A2. Okay, so this is the initial condition. So you can see the fault is occur at A2. Okay, so we go to the result. Okay, so this is the result. Okay, as you can see, relay A and relay B are both trip. Okay, so we try to mitigate the false tripping on relay B. So we add additional power supply on bus A. Okay, and then we run this simulation. Alright, so as you can see, the fault is still occur at A2. So this is the result. Okay, the result said relay A trip and relay B also remain trip. That's mean relay B is remains experience false tripping. Okay, then we go to okay B. Okay, this is when we add additional supply at bus B and the fault is occur at A2. Okay, and then we run the simulation. So okay, as you can see, okay, so this is the result. Alright, for bus B there is remains trip. Okay, the trips, okay, which is improved, but relay has gone a protection blinding state. Okay, this is the unwanted. Okay, relay A should trips, but it went not trip. Alright, that's all. Thank you. For project features, the simulation of this project is using Power System Computer Aided Design (PSCAD) software. Then the simulation is based on the operating time of overcurrent relay. For novelty and inventiveness, there are two. First is the presence of distribution generation on the grid system. Next, introduce the auxiliary power supply on the grid system. For project potential of commercialization, it can be applied by electric railway operator company as a method for assessing the availability of overcurrent protection system. Okay, I would like to conclude that the presence of distribution generated in distribution network is beneficial to the customer and also challenging in the protection system of the network. New technology of protection is needed for improving the traditional overcurrent protection.